All right, why don't we go ahead and get started? Hi, everyone. Thank you so much for joining us. I think I know most everyone here, but for those I don't, I'm Rebecca Tromble. I'm director of the Institute for Data, Democracy, and Politics here at GW. And I'm really pleased that everyone could join us for today's Research Spotlight session. This is the second in our series highlighting the research being conducted by IDDP's inaugural cohort of research fellows. And today I'm particularly pleased to welcome Dr. Kai Xu to speak with us. Dr. Xu is the Gladwin Development Chair Assistant Professor in the Department of Computer Science at Illinois Institute of Technology. And today he's going to be talking about the work he's been conducting on strategies for disinformation detection using social context as a key factor. I'm particularly interested to learn more about this, something that I've been interested in for quite some time now. And I believe he'll also be speaking about some of his plans for future work following on from this project. So thank you so much for joining us, Kai. I'll turn things over to you.
Thanks, Rebecca, for the nice introduction, and nice to see you all here in the Zoom. Hopefully we can meet sometime in the future in person. But yeah, let me share my screen. Okay, cool. So I hope everyone can see the screen now. Okay, great. Again, it's my great pleasure to talk about our recent research towards social context-aware detection and understanding of disinformation. Again, I'm a country assistant professor at Illinois Tech. So I want to start with this recent post from Forbes about 10 wonderful examples of using AI for good. As you can see, spotting fake news has attracted tremendous attention in both academia and industry, and is among one of the examples of using AI for good. But as many of you already know, that fake news is not a new problem. Its detrimental effects are actually amplified by the use of social media. Social media has become a kind of popular means for information sharing because of its easy access, low cost, and wide spreading. And the number of people using social media platforms are increasingly fast over the years. And actually, a recent post just coming out yesterday from Pew Research Center shows that about half of Americans, they get news on social media, at least sometimes. And still there are around 67% of Americans, they get news on social media in 2021, even though slightly decreased from last year because, the reputation of social media has kind of affected by fake news, but still there are 6-7% of them. But however, social media is like a double-edged sword, I would say, because it also enables the widespread of disinformation, including fake news. Disinformation is commonly treated as the false information with a bad intent to mislead or deceive readers. And fake news is an example of disinformation, indicating the news that is intentionally false, right? As many of you know that disinformation is rampant on social media. For example, a study shows that the COVID-19 disinformation has been widely spread and causing the infodemic issue. As you can see, actually published recent paper as shown on the bottom. I participated in this WHO infodemic conference, and we summarized this kind of relevant issues and challenges to tackle the COVID-19 related disinformation, and you can check this out. And also fake news can be diverse in terms of topics, such as politics, business, natural disasters, and so on. Okay, so these are all very important challenges of disinformation. And a natural question we want to ask is why we need to study fake news or disinformation. From a psychology point of view, humans are susceptible to fake news due to the limited resources such as limited time, limited information, and limited expertise for a normal person. And also humans are biased, right? Because, for example, the confirmation bias theories that indicates people tend to believe information that confirms their existing knowledge, no matter it's fake or not. In addition, fake news can have detrimental society effects. It can mislead people to false information, can change the way people respond to true news and even weaken the public trust in government and journalism. So why combating disinformation is such a challenging problem? Why? It is complicated in many dimensions. First of all, the topics are dynamically changing, and a model designed for the current may not work in the future. Okay, and there's often very limited annotated data, and it's very challenging to build some machine learning or AI models to automatically detect. And the social context is rich, but it also can be very noisy and biased, right? So to tackle these challenges in this talk, I will mainly focusing on our study about context-aware models to identify and understand this information with 3 representative tasks. First is how we can model emotional signals to improve the fake news detection. The second one is how can we detect fake news with user preferences incorporated. And third is how can we understand the fake news dissemination process from human behaviors on social media. Okay, so next I will introduce 3 recently published papers under the support of IDDP Research Fellowship. First, we want to understand whether emotional signals from news content and social engagements can help detect fake news, and how. Second, since users in social media, they have different interests, and we discuss how to improve fake news detection with user preferences. And third, social media data is often noisy and biased, so we want to explore how to use causal learning to understand fake news dissemination. Okay, so next I will start with the paper on mining dual emotion for fake news detection, which is published in the Web Conference 2021. So, research from social science and computer science has demonstrated that fake news and real news, they can arouse different types of emotion reactions. Okay, existing research largely focusing on the emotion from the news content itself. For example, sentiment features such as the fraction of sentimental words, exclamation marks, emotional lexicons, they have been explored, okay, to detect fake news, but they are mostly extracted from the content itself. However, in a real world scenario, the news contents and user comments, they are inherently related, and they can provide important cues to extract emotion signals. So in this paper, we define a new form of emotion named dual emotion, consists of 2 sources of emotion signals, publisher emotion and social emotion. So publisher emotion basically is derived from the news content, and social emotion is indicated from the social engagements, such as comments in Twitter, okay? So essentially, there are 2 cases of dual emotion, resonance and dissonance. So what do we mean by that? So for example, as you can see on the left figure, we can see that the fake news content shows an emotion of angry, including the words like disgusting, killing, and the social emotion in the comments is also angry with the words such as killers, disgusting, right? So this indicates a resonance relation between the published emotion and the social emotion. But on the other hand, on the right side figure, we can see the content and the comments, they both indicate an angry emotion, which indicates a dissonance relation, okay? So in this work, we want to answer the following questions based on the observations we just see. First question is, would this dual emotion be helpful to detect fake news? And how to model the interactions in these dual emotions, okay? So basically our objective is to build an end-to-end framework to jointly model the dual emotion and the relation and the interactions. However, by only considering the emotion signals may not always have a good performance because the semantic information from the news content is also important, right? So in this case, to tackle this challenge, we propose we call it model agnostic approach, which can adapt the different fake news detector with the following 4 major components. It looks complicated, but basically the first component is we want to learn is called publisher emotion, which we learn the representation from the news contents, okay? And then the second is a social emotion module. We can capture the emotion from a set of comments. And third is we want to model the emotion gap between the social emotion and published emotion so that we can model the interactions between these two types of emotions. And last, we incorporate the fake news detector, which can model the semantic information of the news. So finally, these features we can concatenate them together, and then we can predict whether a piece of news is fake. Okay. Note that here we just use for example, this by GRU is one very typical deep learning framework for fake news detection, but we can change it to others because this framework is kind of model agnostic. Okay. So in the experimental evaluation, we used existing real-world fake news data sets with the social engagements collected from social media sites such as Twitter, Reddit, and Weibo. And we observed that the extracted dual emotion features are more effective than existing emotion features, as I mentioned in the existing work. We also observed that these dual emotion features can help different content-based fake news detectors to consistently achieve a better performance than others. Okay. So, I mean, to summarize this work, in this paper, we basically verified that this dual emotion signals is different from fake news and real news. And based on the observation, we propose a set of dual emotion features that can be incorporated into different fake news detectors to enhance the performance. And then at last, we demonstrate the effectiveness of these features in the real world data sets. Okay. Any questions for now before I move to the next piece of work? Because I just try to give a high level idea and the framework. I didn't go to too much details of the model. But yeah, any questions before I move to the next?
Yeah, if you don't mind, Kai, I have so if you don't mind backing up a little bit on the conceptual part here.
Sure.
And explaining just a little bit more what specifically you mean by the dual emotion that's involved here. So you moved through this particular slide. I'm glad you went back to that just a little bit quickly. And in one of the examples you have, right, the publisher to comments being angry, and then in the other, the the happy to angry.
Yeah.
And is one of these the dual and the other isn't, or how is this factored in here?
Thanks for the question. Yeah, basically, so first of all, I would say emotion signals is not new kind of dimension to look at fake news. But if you look at computational approaches to use emotion signals, most of them they only use the emotion from the news contents, or they use it from maybe the social comments. But in this paper, our novelty, what we want to do is we want to combine these two together. That's why it's dual, because it consists of two parts, publisher and social emotion. So basically the definition of dual emotion is to look at both publisher emotion and social emotion and their interactions. So in this example, I want to show you that on the left side, it's possible that publisher emotion and social emotion, they're the same. Both of them, for example, they're angry. And it's also possible that publisher emotion and social emotion, they are different. And similarly for real news is the same, right? Basically, for real news, you can also have this this publisher emotion and social emotion, they agree with each other or they don't agree with each other. So actually, we have done a lot of data analysis we haven't shown here to look at whether the patterns of, for example, we have 4 cases, agree or disagree, fake news and real news. Basically, it's like 2x2 matrix. We look at the distribution of these 4 cases and we see that actually it's different. For fake news, the probability of we see this resonance and the dissonance cases are very different from real news. So we say, oh, okay, this probably indicates that by looking at these 2 emotions together, it can be a very good feature to detect fake news. So our assumption is based on this extensive data analysis, and then we encode this kind of dual emotion features into an end-to-end deep learning framework. So that's basically how we define dual emotion and why we think dual emotion can be helpful. And then by by encode this dual emotion in the model, we do some experiments and demonstrate the effectiveness. But yeah, that's basically the idea here.
Okay, all right. So I was a little bit confused about whether it was the combination of the two, of the publisher comments, or actually the disjunction between the two, but that makes it clear. But I'm really curious about this 4x4 model, or 2x2 model that you've described. And what you just said a second ago about there being a difference in what you've observed between disinformation, right, news through disinformation, and quality information, quality news. Where would you say those two in your grid? Where is one versus the other more likely to fall?
Yeah, so we do have a detailed analysis in the paper, but basically you're right. We have, I can quickly draw something like this, right? As you said, is each row, for example, this is fake, this is real. Oh, sorry, this is, for example, the publisher emotion, and this is the social emotion, right? So they can be angry, they can be happy, and then they can be angry, they can be happy. So as you said, it's a grid of these 2x2 combinations. So what we do is we look at this matrix for fake news corpus, and look at this matrix for real news corpus. And then we use some statistical measure to compare whether they're significantly different or not. And it's significantly different based on some measures. That's why it motivates us to say, oh, okay, it probably is useful, but how can we use that? That's why we divide the model as shown in the next slide. So that's basically the logic here. But yeah, we do have different metrics and statistical measures shown in the paper. I didn't have too much details put in the slides, but yeah, we do that analysis.
But can you sort of concretely point me to, which is more representative of which type of fake news?
Yeah. So one example I will just a little bit detail here is that, as I said, this matrix we look at, for example, we have two matrices. One is for fake news and one is for true news. Okay, and then we look at, for example, the fake news, the portion for this part. I mean, for example, this is angry, this is happy, this is angry, this is happy. So similarly for this one, and then this is for fake news, this is for real news. So we look at distribution. For example, this part is significantly different from real news. For example, we look at the numbers, right? For example, this is like 80% of them. This is like 10% of them. This is 70% of them, or something like that. So we look at which part takes the most portion. Is it, for example, if both fake news and real news, they are pretty much similar, this one is the biggest, this one is smallest, then we say probably this feature is not important because they're very, very pretty much aligned with each other. But doing analysis, we see they're not aligned with each other, basically. Yeah.
Okay, thanks.
I can provide some.
I'll let you move on.
Sure, I think it's a great question, and I can provide you some detailed observations for this and point to the paper. But essentially, our conclusion is that this distribution are different. That's why we think it's probably is useful. Yeah.
Great, thank you.
Thanks. Yeah. Great. Let's move to the next. Okay, this one. Okay. Right. So, in the first paper, we have shown basically the emotion signals, specifically the dual emotion signals, can help fake news detection. But since the news is actually propagated in network structures among the users, right, among the social media users. So next, I will introduce a paper published in SIG-IR called User Preference Aware Fake News Detection. Okay. So again, in social media, news propagates in a hierarchical structure, which may involve useful information to help detect fake news. As you can see in this figure on the bottom, it can be represented as a tree structure, okay, as shown in this figure on the right side, including the news pieces and the engaged users. Okay, that's how we can basically represent news propagation network. Well, there are some existing work, again, explored these hierarchical features from different perspectives, but it still requires extensive feature engineering, which cannot be easily generalized. What do I mean by that? For example, what they do is they look at this hierarchy, this propagation structure, and then they probably look at the, for example, semantic feature, temporal feature, or the structure features, but based on their own knowledge, right? So it's a list of features that they extracted and based on their own knowledge, but probably cannot be generalized into other domains. So that's the issue. In addition to that, the user consumption patterns, they are considered separately for different news. So for example, as you can see in this figure, for each piece of news, we can construct a propagation pattern. And then for some other news, maybe news 2, we have a different network. For news 3, we have a different network. So you can see these different propagation tree, they are considered separately. And some common patterns across these different users, they are not considered. Okay, so to tackle this issue, what we do is we want to incorporate this user's historical preference information. So how can we do that? So our motivation is basically that according to some social theories, for example, the confirmation theories I just described, people tend to consume news that confirm their existing views or preferences, right? In addition, a user engaged in fake news may have already shared some similar news pieces before. Okay, so based on these observations and theories, in this paper, we want to understand, first is, would user historical preference be helpful to detect fake news? And if so, how can we learn from this multi-model information in the propagation network for fake news detection? So what do we mean by multi-model? Because it can be semantic, it can be structural. So this information, they have different modality, okay? So we face these challenges. So in this paper, our objective is to build a fake news detection framework that can jointly learn the semantic and the structural information in the news propagation network. Okay, specifically, given the news piece and the correspondent and engaged users, first, we propose we call it preference encoder to extract the features of the news contents and the user's historical posts, like user's historical tweets, okay? So we use pre-trained word embedding. And second, we fused this graph structure and user preferences with the news textual information together using a deep learning called graph neural network, okay? So now we are able to model both this preference and the context. And then we just concatenate, at last, we just concatenate these features together. And then we feed into a kind of, we call the neural classifier to predict whether a piece of news is fake or not. Okay, this is basically the idea of how we are able to model these two types of information. But again, before I move to next, any questions about the motivation here, why we do that, or do you think it makes sense, or do you have any suggestions for that? Basically is we want to use this propagation network, and our novelty or our difference is that we not only consider this propagation network separately, rather than what we do is we also consider the user's historical post. Okay, for example, here, what this user has already posted in the past. We look at this information as well to better correlate this different propagation network. But how to do that? We just propose this model, which is not, again, it's not very, probably it's a bit complicated and detailed, but the motivation should be clear of why we do that. Okay. So with this method, we again do some experiments on real-world data sets. Here we test our method in the fake news net data sets. Consists of two domains. One is from the PolitiFact, and the other one is from GossipCop. It's about kind of entertainment news. The PolitiFact is more about political news. So we do this. We test this method and compared this method with existing fake news detection methods, and we observe that this proposed method can outperform very different fake news detection baselines. And we also do an ablation study. Ablation study, we just try to eliminate different components of our model and see whether each component helps. Okay, through this ablation study, we show that the user preference actually plays a very significant role in fake news classification. And we also try different kind of, because we have two types of information, right? Graph and text. So we try different graph and text learning method. And then we see that in different data sets, probably different graph and text encoders, they work differently in different data sets. Okay, so yeah, that's basically the experimental result we have. To summarize this work in a high level, basically, we propose a new fake news detection method by incorporating the user preferences, okay? And then we propose a framework which can jointly model the heterogeneous information because we have text and graph data, okay? And we also demonstrate that this endogenous preference and exogenous propagation context, they contain complementary information, essentially meaning that it's very important to both consider the network structure and also the user's historical post to measure his preferences, okay? So that's basically what we have for this paper, okay? Any thoughts, any comments for this? Cool, okay. So now, we have introduced two papers to improve the fake news detection with context, right? We talk about emotional signals as context, and we talk about this user preferences in the propagation network as context. So next, I will move a little bit to talk about how to understand the fake news dissemination instead of detection, okay? We use causal analysis method, and we specifically want to focusing on this biased social media data. How can we do that? And this paper is published in KDD 2021, okay? As I said, there has been quite some progress on detecting fake news in recent years with computational approaches or the mixed methods. However, the understanding of why people spread fake news is still unclear and is still limited. So the goal of this work is to learn from the user behaviors of fake news sharing on social media to understand why people spread fake news on social media, okay? Essentially, we want to answer these two questions. First is, would user behaviors be helpful to understand fake news dissemination? And how to identify the user attributes that can cause the spread of fake news, okay? So in a real world scenario, actually we can treat the fake news dissemination process as we call the bipartite graph. As shown in this figure, okay? The left side, let me do some. So the left side of this graph are these social media users, and the right side of this graph are all the fake news pieces. And the links are formed only from the left side to the right side, indicating whether a user shared a fake news or not. For example, here we have user U1 shared fake news I2. So there's a link between U1 and I2. Okay, so this is how we can use a graph structure, specifically the bipartite graph, to represent the news dissemination process. Okay. However, learning the sharing behaviors is very challenging because of this selection bias in the process. Why? What do we mean by selection bias? So first of all, users, social media users, they have their own self-selection bias. Okay. For example, in social media, users typically they follow what they like, whatever they're interested, right? So this is kind of a bias. And secondly, the actions of these online media platforms, they can introduce bias. For example, like the platforms like Twitter or Facebook and others, they tend to recommend these news pieces that they believe of interest to the users. Okay, because of this, the bias from the users is themselves and from the platforms. So the collected bias data, they can only partially describe how users share fake news. Okay, why is partially, and how we can do that? How we can solve this issue? Okay. So to alleviate this kind of selection bias, we propose to use causal learning as a method to model the fake news dissemination. Okay, so our assumption is that, you know, a user spreads fake news if and only if he or she is both exposed and interested to the news. Okay, as shown in this equation, we have this YUI, meaning that this user U will spread news I is dependent on OUI, indicates that this user has been exposed to the news, right? If the user has never seen the news, of course, he or she will never have the chance to spread it, okay? And this user is interested in the news, measured by RUI, okay? So that is our assumption to formulate this problem. But both the exposure and the interestedness, they are unobserved in the data set. For example, whenever you collect Twitter data set, you never know whether this user has been exposed or not. Of course, if he or she's already spread it, of course he or she's exposed and interestedness. But how about other links that is not formed, right? For example, here we know that user UI and let me annotate something. Yeah, so we know user UI and news I2, they have a link, then it's spreading. But how about user UI and news IN? Even though there's no link, we cannot say U1 has not spread fake news I1. Probably the user U1 has never been exposed to the fake news IN. Okay, so this is something I want to highlight here. So again, let me delete this thing. Okay, so to solve this issue, we try to debias this sharing behavior using a method called inverse propensity score, which is a widely used mechanism in causal learning. So I will not go through the details of this method, but essentially, this inverse propensity modeling, or IPS, it works as a reweighting mechanism by assigning larger weights to the news that is less likely to be observed. Okay. So after we can learn this unbiased sharing behavior, we further identify the user attributes to measure the user susceptibility to fake news. Okay. So what we do is we assume, first we make assumption that if a larger portion of news a user has shared is fake, then this user is more susceptible to share fake news. So as we already show here, we can define this, this variable BU to indicate the susceptibility of the user U. Basically, it can be calculated as this formula. It's very simple. So this one indicates how many of fake news pieces this user has shared. And this one is how many of true news pieces this user has shared. So this proportion or this fraction indicates, if this value is very big, indicates that maybe for this user, out of 100 pieces of news he or she has shared, 90 of them is fake. Then it indicates that this user is more susceptible than others. Okay, so this is the idea. That's why we use this formulation. Okay, based on that, we can build a causal model to identify the causal user attributes to estimate their effects with this linear objective function. Okay, so this is the BU we just calculated. It indicates how likely this user is susceptible. And then AU is the user attributes. For example, in Twitter, we have the user's age, gender, verified or not, number of followers, number of followees, number of tweets, and so on. So this A is a feature vector indicates all these attributes. And then this U is the learned shared behavior representation we just showed in the previous slide. So the causal attributes can be obtained or can be derived from the value of this beta. For example, if we have a bigger beta value of number of tweets, indicates that this number of tweets is a causal attribute to make the user to spread fake news. Okay, so this is what we can get and what we can learn from this formula. Okay, so basically, in this slide, what I want to say is that we want to identify this specific user attributes that make this user to spread fake news. And what are they? We want to understand that by looking at this parameter beta. Okay. Okay. Any questions before I move to the next? Probably, I hope it's clear for the motivation at least. Okay. Great.
I have a question about the confounder.
Sure.
Sharing behavior. A little bit more on that part.
Sorry, because your voice just.
Oh, okay.
Yeah.
So probably in the next slide. I'm not clear. Can you explain a little bit more the confounder sharing behavior? I'm kind of.
Sure.
Yeah.
Yeah.
Thank you.
Thanks for the great question. So basically, we have three variables in this process. So we have the variables of this user attribute. Okay, I say user attribute, and then we have these sharing behaviors indicating from this the earlier graph, bipartite graph, and then this is the user attribute, this is sharing behavior, and this is the news. So in this case, we say this sharing behavior is confounded because you think about because we want to know why people spread fake news. What kind of attributes makes he or she spread? But there are some confounders, make this causal process not make this complicated because this sharing behavior cannot cause the spreading of the news, right? So that's why it's confounded because we want to understand basically if you look at this causal graph, we want to understand this one, but we need to eliminate these two arrows as confounder because the sharing behavior will affect these user attributes, and then will also affect the news sharing. So we want to eliminate these two. But basically, by using the previous model, we can learn we can learn an unbiased sharing behavior, and by using this one, we'll kind of eliminate the confounder to learn the real causal relation between the attributes and outcomes. But yeah, we have made some causal assumptions here. I didn't have time to talk to my details. But yeah, in the paper, we have this figure, and then you can take a look.
Okay, thank you.
Thanks. But yeah, then experiments, we have done two types of experiments. First one is we want to verify by learning this unbiased embedding, is it helpful to help us to predict the link in the bipartite graph, right? To predict whether a user will spread fake news or not. That's the first task. The second task is we want to see what are the attributes we learned from this user attributes that caused this user to spread. Okay, so in experiments we observe that the proposed model can predict fake news sharing behavior more accurately. Okay, so we have this last row is our model, and this one is some baselines. We can see by looking at the precision and recall, we can see our model can more accurately predict the links in the bipartite graph. Okay, and then we also show that by using this unbiased user embedding, it can improve the prediction of susceptible user. Okay, essentially, what do we mean by that is by using this formula. Okay, by using this formula, we can better predict BU. Okay, by using this unbiased sharing behavior. And the third is we actually observe that some of the user attributes, such as number of friends, number of tweets, and whether it's verified or not, these attributes can causally affect whether this user will spread the fake news or not. Okay, based on the two data sets we have experimented with. Okay, so basically to summarize this work, first of all, we model this fake news dissemination process in the user news in a user news bipedal graph. And then based on this graph, we are able to learn an unbiased news sharing behavior by using causal inference methodologies. And we identify the user attributes that can potentially cause the user susceptibility, and we can estimate the effects. Okay. So I have introduced these three representative work, and for future work, I think there's a pressing need for interdisciplinary research. So first of all, how we can integrate the theories from different disciplines, such as social theory, narrative theories, to really build the machine learning models to detect fake news, right? Especially when we have very limited label data. Okay, one promising way probably is we can learn from some we call weak social supervision to really encode these theories into the methodologies with weak supervision technologies. Okay, and how can we explain computational results to benefit the domain experts like social scientists and journalism and decision makers? So we want to develop some explainable and interpretable models using either like causal learning or data-driven approaches to really explain the results. Okay, and then how can we use advanced AI and machine learning technologies to help combating disinformation, given that the problem of disinformation is actually amplified by the power of deep learning models and their capacity of generating like deepfakes or this we call it machine-generated text. Okay, so in the next phase of my research, I will focus on these different areas, and if anyone of you is interested, please feel free to reach out to me, and I'm very happy to discuss with you all these challenges. Okay.
Thank you so much, Kai. I want to that was the end, right? Are you ready for questions? I don't want to cut you off.
I want to have the last one.
Oh, sorry. Okay,
so
please.
Again,
go ahead.
I want to thank, I want to thank IDDP for this support for my research, and I want to share 2 data repositories and 2 books. All of them, they are public online, and thanks again for this opportunity.
Thank you. That was great. So I want to open the floor up to questions now. I know that I have a couple, but I already asked a couple, so I'm hoping that others will jump in.
Hi, Kai. I have a question. First, thank you very much for the presentation. So my first question is about your third paper. After you talked about model, you said you did an experiment. I wonder why you decided to do an experiment instead of using real-world observational data, and how did you do the experiment? What is the control group, and what kind of treatment did you give? So that's my first question. My second question is on your first paper. Could you talk a little bit more about the data that you train your model on, and what kind of data did you have? What is the time period they cover? What are the topics of the news content or fake news content do they cover? And do you think your model can also do well on out of sample data or data in the future that we haven't seen? Thank you.
Thanks for the great question. The first question is about the third paper, is how we designed experiments, especially how we define, for example, a control group and the other treatment group. So in this paper, first of all, we're not doing this kind of traditional random experiments, because what we have is just observational data. We just can observe whatever this bipedal graph we can build. But rather, when we do experiments is, we compare, using the same observational data, we compare those models that do not consider this bias in the data set collection. And then our model consider this potential bias, and then we propose a debiasing techniques using this IPS, propensity score matching method. And then we compare which one can achieve better performance. And any experiments, especially for this classification task, we need to obtain ground truths of the label that we can compare. For example, in the third paper, essentially we have two tasks. First task is we want to predict the links in the bipartite graph. A second task is that we want to predict the user susceptibility. So we have to obtain the labels for these two. The labels for the first one is obvious, is whatever already occurred in the links are the labels. And for the second task is we define this new measure called BU, we just described by using the fraction of the denominator, the fraction of the number of fake news this user shared divided by the number of both fake news and real news shared as the ground truth. So we look at this, we have to make some assumptions for this ground truth, and then we just compare the models to see which one can better predict as close as possible to ground truth. So short answer is we haven't done this, for example, the traditional counterfactual way to have a kind of treatment group and control group. We haven't really do this kind of causal learning, but rather we use the same data set, but define some ground truths and then to see which method can better kind of predict as close as possible to the labels we define. For the second question is about data sets. So for these three papers, we all use these real world data sets, especially for the second one and third one, we use this data set, at least here, fake news net. Okay, so this is data set we are using and it's publicly available. We have a GitHub page there. Basically, it contains two domains. One is it's collected from PolitiFact. I believe many of you at IDDP also use that from PolitiFact. And the other one is from Gossip Talk, which is a kind of from the domain of entertainment. We are also extending this new data set to have this COVID. This is a new data set we have curated related to COVID-19. Again, it contains rich information, including the news content, social engagements. As you said, there's temporal information, the time period, and topics. So we have all this information. Regarding about the time period, actually for fake news net is collected during 2017 around the election season. So most of the news is about at that time. The period is about 2017, the end of 2017 or beginning of 2018, I guess. I cannot remember very clearly. But for the COVID, it's more about the COVID-related fake news and real news. So it's more recent. I think it's around sometime from 2019 to 2020. So this is about time period. And regarding about this, the last question you asked is about whether whatever model I developed here can be kind of adapted to kind of auto domain setting. Actually, I have one paper I haven't introduced here. It is ongoing, we just submitted. The idea is we want to do some domain adaptive fake news detection by using some transfer learning or adversarial learning techniques. Basically, the goal is we want to train some machine learning model in a domain that has a lot of data sets. But for those new domains that has very limited data, how can we adapt and predict this fake news effectively, right? So we build some transfer learning techniques or domain adaptation techniques. We also call domain adaptation techniques to help predict. But short answer is all these three works. The focus is not on out of domain setting, but I agree this out of domain setting is has some additional challenges we need to tackle, and we're working on that right now.
Thanks, Kai. And I just want to make a quick note here that Yun-Kang, I appreciate the first question that you asked about experiments because it illustrated in real time for us some of the challenges of this type of interdisciplinary work because computer scientists, data scientists tend to use the term experiments and mean something very different from what we as social scientists mean by experiments. And often I will talk to the computer scientists that I work with about the experiments I'm about to run, and they're like, what are you talking about? What type of experiment? And then we have to do the backup and say, oh, no, I mean this type of experiment, not that. So that's good.
That's good to know, yeah.
Yep. Okay. Are there other questions?
I have a question for the first paper. So very interesting. I'm just wondering, So when you mentioned there's a two emotion, the dual emotion, there's a publish emotion, the social emotion, and then so the social emotion that then using the like observe the big significant difference between the two distribution of the patterns. I'm just wondering, the social emotion really depends on the comments for some link, like a given or publish link. But what's the diversity of those comments? Like is because to my what I'm thinking is based on how diversity of the comments and then or diversity of the group of the comments, the social emotion can be very mixed or can be very say homogeneous. So the gap, the pattern, when you compare those two patterns, so the publish emotion probably more fixed, while the social emotion is more flexible. Then you compare the difference, the gap with the two, how you control those, I think the factor, yeah.
Yeah, I think, first of all, thanks for this question. I think this is a really great question. So basically, if I understand it correctly, is when we look at a set of comments related to a news, how can I control this quality of these comments? At this point, short answer is, in this paper, we haven't really looked at the, for example, who are the users of published comments? Are they credible, or should we sample part of them, or should we consider all of them? So in this case, in the paper, we because this is kind of first work to explore this, we just treat all the comments that we can collect from the social media platform as a group of comments, and then we analyze the sentiment of each one, and then we have an overall score of whether it's more angry, more happy. So we have a kind of aggregated emotional score from this set of comments. But I totally agree with you that, first of all, we should care about who are the users who publish comments. Maybe most of them, they're bots. Most of them, they're cyborgs. They're malicious users. Then should we still take their comments into consideration? That's the first question. And second is, is there a way to kind of filter those kind of noisy comments instead of consider all of them? Actually, I had another paper published in 2019 is about explainable fake news detection, which we also look at the comment to explain why a piece of news is fake. But what we observed that some of the comments, they're very, very noisy and it's not very useful. So we probably need to filter out some of the comments before we do whatever modeling we want to do. Like this, we want to extract emotion signals, or we want to use comments to do explanation. We need to be very, very careful about the comments we have included and analyzed. We probably need to consider user credibility. We need to consider the quality of the comments. So, but yeah, I think this is very important to consider diversity of the comments to get a probably more accurate kind of prediction instead of just treating them all equally important because they're not equally important, right?
Okay, thank you very much for the clarification answer. A following up question about this is, I'm just wondering because so the detection is based on this emotional, like you observe the significant difference between the two patterns. Then for social scientists, always wondering is what's behind it. Why the gap leads to this fake detection, like efficiency. Right. So during the analysis, do you observe or can conclude the logic behind this? Why this is the case?
Yeah. Again, thanks for the great question. So the short answer is that we also want to understand why, but usually what we do is, a typical pipeline for kind of data science research for fake news is, first of all, we make some assumption. First of all, we say probably dual emotion is important, but then we need to verify this assumption by doing, we call data analysis. So as I showed earlier with this different matrix for fake news and real news, we utilize some statistical measures to kind of to demonstrate these different patterns that indeed very different. But how we can do that, there are some measures we detailed in the paper. But I agree with you, is like what other patterns, how can we interpret these differences? This was a very important to really kind of make some explanations, right? This part probably we need to work with social scientists like maybe like you and others in IDDP to really dig deeper. But yeah, we can't do it just based on these statistical measures, some numbers, and then we look at the differences, and then we have the motivation to design models. But it's worth to look at what is behind these numbers and how we can better interpret them. Yeah.
Thank you.
Thank you very much.
So just to round things out, Kai, I really want to thank you for taking the time to present to folks at IDDP and beyond. Thanks to those who came today to listen in and those who asked questions in particular. Really look forward to learning more about your work as it goes forward. And Kai, I think there were some moments in there that really piqued my interest in terms of sort of fleshing out some of the more interdisciplinary work and angles that we might take with this. I didn't want to take up too much time, but on that third project in particular, you know, you were really coming close to a number of rich communication theories that I think actually could help, you know, enrich both the computational and the social science work together. So lots more to follow up on that. Thank you to everyone. I hope you have a good rest of the afternoon, and we will see you for the next Spotlight series.